I'm looking at what I've called the foundation. And what's the derivative with respect to x of this? That is -1 to the front, 1 minus x, that's to the -2. Chain rule, you would have times -1. So the two negative ones give you +1, and that is 1 over 1 minus x squared. So while the idea of we could do 1 over 1 minus x times 1 over 1 minus x would be okay, this is a little bit better. I can look at this and say, well, this is the derivative of this. And so from 1 over 1 minus x, I'm going to write out a few terms here. This is 1 plus x squared plus x cubed plus x to the 4th plus ... And so the derivative of 1 over 1 minus x is the derivative with respect to x of the power series and I know this derivative is actually what we're trying to get. So 1 over 1 minus x squared equals, well, derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x. The derivative of x to the 3rd is 3x squared. The derivative of x to the 4th is 4x cubed. I didn't write the next term. It'd be x to the 5th, and its derivative is 5x to the 4th. So there's power series. Now, if I want to write it in summation notation, actually we could have done this. I could have written this, well, let me write d over dx in the front of that, of x to the n, and I could just take the derivative of that. And that's n equals 0 to infinity. Now, maybe I don't necessarily want to keep that 0 right here, but here, let's go from here. So this is the sum, as n goes from 0 to infinity, of n times x to the n minus 1. I just did the derivative of that. And now, the first term here would be 0. This one, right, maybe we'll just say that this is the sum as n goes, maybe I just want to start it at 1. N goes from 1 to infinity of n times x to the n minus 1. Since the first term is 0, I could do that.
It's not a problem, though, right?
I think it'd be okay if you left it like this. I'm thinking, is this undefined? X to the, well, it might be undefined when x is 0.
But those are going for all of ours, or for the majority of ours. Because we ended up with x to the n, so if the 0 term for x is 0, we would have had 0 to 0.
Would have had, okay.